Hey, it's John and Mike, brew-news.com, and he's got his laptop here, so you know it's important. But I'm going to learn about this for the first time. I know you guys are sitting at home watching this on either your TV or your tablet or your phone or whatever, but I'm here live, and I would like to know more about this strange 5-beer project.
The 5-beer project.
But you were like dialing in water chemistry and mash temp and all kinds of stuff. I don't know what's going on.
Okay.
So that's why I'm just going to drink this beer and listen to you.
I'm just brewing beer, man.
No, you're not just brewing beer. You're like perfecting beer. And you're doing it without my knowledge.
Beer with
you're
a capital
B.
B.
You're not sharing anything.
Yeah.
You're just like, hey, try this.
Try this.
Try this. What do you think of this?
Yes.
Well, I'm getting there.
Yes.
I'm getting closer to perfection as you're sitting in the sidelines.
So the story begins back in a small farm. No. So during 2017, 2018 at least, right? I've struggled with some beers attenuate well, some beers don't.
Yes.
And I couldn't really nail down why that was.
I see.
So some beers are, I'm happy with them. A lot of beers I'm not so happy with them. So
it's all because they're not hitting the final gravity that you think they
basically,
should hit?
and how that translates into flavor profile, right?
Yes.
Right. So, so the thing is, ever since I built my brew stand and transitioned to direct fire mash tun, whatever, I began to realize that every time I brewed, I would brew differently, right? Because I was always experimenting with
trying something
tweaking
different?
the equipment this way, trying to learn something about using equipment that way, whatever. And you know for a fact that every time that I've come to your house when you're brewing, I look at your process and I go, why do I have to make it so complicated, right? Why can't I just brew that way? Because your beers are always excellent and on point, or at least you're hitting your target, right? Of what I tried this is what it came out. Maybe I would change it, but this is right. For me, it got harder and harder for some reason to feel like I was learning anything about recipe or ingredients, or even being able to talk intelligently about water chemistry when there was something flawed about my process.
So you had multiple variables in your process.
Too many variables to be able to equate to why is the end result taste the way it is. So I said, you know what? I gotta totally shake it up. And so I came up with this idea in my mind of doing what I called the 5-beer 10-pound project. So what I did is I said, okay, I'm going to dedicate myself to one way of mashing, one process for boiling, and one process for chilling. Put them together as the process. And not sort of try to change it. And I was going to stick to that process for 5 beers no matter what. Even if at the end of 2 beers, I learned where my mistakes were, where my problems were, or 3 beers in, I figured, oh, this is why I don't attenuate, right? I'm going to do 5 beers. I'm going to stick to those 5 beers. And now the question is, why is it 5 beers? Because so what I did is I bought a 50-pound sack.
That's why.
But listen to the madness, right? So I bought a 50-pound sack, thinking I will do 5 beers, all with 10 pounds of base malt, to keep that variable the same, so I can track efficiency.
Got it.
Right? So I can track efficiency, and so I can also track mash, like pH quality, right? Am I doing the right thing each time? Is the result the right thing every time? Then also, do I get the right attenuation? That was a big thing for me, to get the right attenuation. Because I wasn't sure whether attenuation was a yeast issue. Am I pitching enough yeast? Or was it a fermentation issue? Like, is it because my temperature's up and down? Or does it have something to do upstream, like the mash? Is it because I'm direct firing the mash? Or is it because maybe my mash pH is way off and I just don't know, right? So, so those were all variables I wanted to, so I figured I would eliminate them by just dedicating. So I bought a 50-pound sack, actually it turned out to be a 55-pound sack, but I got a 50-pound sack.
You got 5 pounds left?
I got 5 pounds left out there, so I'll
figure it out.
with it. Anyway, so I decided every beer would have 10 pounds of base malt. There may be more or less other total malts based on what I decided to put in there. Because I wasn't going to brew the same beer 5 times, because I felt like some variable needed to float just to make sure
Well, that's
that I
how you brew anyway, right?
Right,
I mean, you're not gonna brew like,
I mean, I've been a big proponent of saying if you want to be a great brewer, you should brew.
brew the same.
If you want to
style over and
brew
over.
something great, you can't just ask on 3 different forums, "Hey, what's the best pale ale recipe?" and think it's going to be great.
Yeah.
You have to brew it, and then you need to brew it again. If you want to perfect, like my brown ale,
Yep.
if you want to perfect that beer,
Yep.
you can't just say, "Oh, that's a great recipe." Brew it and expect it to be a great beer. You got to brew it, taste it, and go, "That's really good."
Yeah.
But you know what? I wish it was a little more nutty or a little less this. Tweak it and brew it again. You have to commit yourself to reiterative brewing to get better, 1, at brewing, and 2, to make a beer what it's supposed to be. So what I did is I was going to do 5 beers, and the very first beer in this process was back at Christmas time, was the New England IPA.
Right. The one that went like
That we drank in
36 hours.
Yeah, that we went right through.
Yeah.
The second beer in the process was the English Pale Ale.
Yep.
The third one was the Brown Ale that we sampled last video.
Yep.
The fourth beer is this. American Pale Ale,
Nice.
which we can talk about a little bit
Yep,
in
yeah.
brief. And then the fifth beer, because I was just trying to find that fifth beer, is a repeat of this beer,
Yeah.
but using my homegrown hops.
Oh.
And it's in that fermenter. So
Nice.
we're not tasting that yet.
Darn it.
And I don't fully have the stats, but anyway.
Okay.
So what did I do? So the big thing that I wanted to do was to simplify the process. So what did that mean? As I put my direct fired mash tun aside, and I went back to the cooler 10-gallon mash tun, and I really paid attention to volumes, specifically because I batch sparge. I used a bucket, but I got into a habit where I would just run off into the kettle,
Yep.
sparge, run off into the kettle, and I was sort of having to guess what my volume was because in those kegels it's hard to actually be precise.
Yeah.
Because I don't have a sight glass, I'm not interested in putting a sight glass on. So I figured I was running off into buckets. So 1, really attention to detail. I have this spreadsheet that I put together so I could capture on brew day on paper format too. I abandoned all the logs, all that stuff. I said start over. I would just write down every single number I could that made sense to me, because somewhere in the data would be what
The
I needed
answer,
to know to
yes.
figure out, right?
True that.
So, so I've brewed these 5 beers, and the one thing I didn't do to try to fix fermentation is I haven't made any starters. I just
What?
pitched yeast.
Yeah. Okay.
Right? Because that's
To keep that
that's a whole other question,
standard.
right? Like
Yeah, I
so
guess.
because my brewing beforehand was sort of up and down with whether I made a starter or not.
Yeah.
So was that the issue? I don't know. So I want to just keep that the same.
Yeah.
While I kept the ingredients and focusing on mash pH the right way. So so we'll talk about the water chemistry issue.
Okay.
Okay. So for water chemistry, I recently read Gordon Strong's book on brewing better beer.
Yeah.
And I had a lot of opinions, but when I read his book, a lot of the stuff that I had in my mind is like, I should try this, try that, he actually talked about in terms of how to brew better beer.
Got it.
And for him, and this is something that I felt for a long time, we as a group, as hobbyists, really have overcomplicated and over-mystified, more importantly, water chemistry.
Really?
From the standpoint of the fact that there's 2 things we need to worry about.
Okay.
Water chemistry as it pertains to getting the right mash pH, and that takes super high priority over water chemistry for flavor.
Okay.
The problem is that certain authors, certain people have promoted those 2 concepts as they're one and the same.
Wow.
Gordon Strong doesn't do that though. Gordon Strong's methodology is, what water chemistry do I need to hit a 5.2 to 5.4 mash
Yep,
pH?
yep.
Let's get the mash pH right,
Got
and
it.
everything else will follow.
Yeah.
Right? In fact, every homebrew book you own that has a chart in it that says Burton-on-Trent water was this, Belgian water was this,
Yeah.
right? All of those tables, current research shows those tables are BS.
Wow.
Because those waters are hard to brew with. Most of those brewers were altering the
adjusting.
water. They changed the water.
Good.
So the best thing to do is to focus on brewing beer the best that you can. Don't worry about what they were doing in Burton-on-Trent or what they were doing in Dublin. Make the best beer you can and then season it with your water chemistry in the kettle to either promote hops or promote malt to the point that you like it.
Okay.
And not worry about the traditional aspect of what was going on in some mythical far-off land,
your water,
right?
bro.
Yeah, right. Whatever that means.
I don't know what that means.
Right? Because you know the funny thing is too, if you get in any water calculator and actually try to drive minerals towards those goals, it's hard.
It's insane.
It's not like a natural thing to do.
Yeah, I've tried it. I mean, I've put in like Epsom salt, which I'm like, I don't know why I'm doing this. Like,
exactly. Right.
Silly.
That's part of the problem.
That's part of the problem.
You're distracted by this thing that's been created around you. So the focus for me was using a Martin Brewingard sheet. I'd put in my recipe, and it would tell me, and then I'd look at where my mash pH was. So for what my process is now, is I always take, I have an HLT, I have one of my keggles, I fill it all the way up. I know I can get like about 13 gallons up to a certain mark, exactly where that mark is. I've been treating my water for these last 5 beers with Camden tablets to get rid of chlorine. Yeah. Because that's a problem for us.
Yes, it is.
It's not a ton, but I can taste it. And I think each one of these 4 beers, even if I don't look at anything else I've done, that one thing alone, I think has had a dramatic impact on the quality of the beer. Yeah, I think absolutely.
Camden tablets.
Camden tablets, right?
To get rid of.
So I've experimented with 1 or 2 Camden tablets in the beer while I'm heating in the HLT. So I have a full thing of liquor, of water, and I'm recirculating my pump while I'm heating it, and I'll put 1 or 2 Camden tablets in there, make sure they dissolve in there to treat the chlorine, and then I'm good to go. And then what I would do is I would run off what I needed for mash, which is usually about 4 to 4.5 gallons, and I would adjust with lactic acid based on Martin Brewingard's sheet. Not necessarily a pH measurement, although I started taking pH measurements later on just because I could. I just wasn't trying to do it up front. I just wanted to see if I could taste an improvement. Right away in my very first beer, that New England IPA, my attenuation level was 83%. And on that beer, I went from a 1066 down to a 1010. So that was great. The second beer, which was the English Pale Ale, which had a lot of like residual body and crystal character to it. It shows because the original gravity for that beer was 1047, but it finished at 1016. So I think there was just a lot of crystal malt effect there, but that attenuation level was 73%. The brown ale, which I think was excellent, started at 1042 and went down to 1009 with another 83% attenuation. So now the attenuation is happening. This beer, which is actually inspired by Sierra Nevada Pale Ale, this is Magnum hops with 2 ounces of Cascade to finish. Okay. It's Marisada pale malt. Pale ale malt with just a little bit of crystal. A little bit of crystal, right? To give you that color, because that's what Sierra Nevada is like. But this, I've been drinking this beer pretty hard. This is a great beer.
It is a great beer.
This is a great beer.
It is a good beer.
This beer, 81% attenuation. Yeah. And so the homegrown hops, I haven't taken the final gravity on that, but
it's funny.
This is going to be pretty good.
Just so, because we tasted the brown ale last week. Yep. This seems drier than that one. I don't know.
It's definitely drier. It's definitely.
But again,
but again, because the hop chemistry on this is now a sulfate weighted. Yeah. Right. And so this is the other thing that I've been doing with our water chemistry is, I'm focused on getting the right amount of calcium for the mash pH. Yeah. And then that's what goes into the mash. And once all the wort is collected, then I do the subtraction and figure out how much more sulfate or chloride do I need to get the ratio that I want. And the ratio, it's not all about the ratio, because you could just put in a teensy amount and have a 3-to-1 ratio, but that's not enough for you to affect flavor. Yeah. So it's not just about ratio, which is something else certain authors have told us about. Right? So you have to have enough in there to taste it, and that's why you need to season to taste. Because you might like black pepper in your clam chowder, and I might not. But just to say that it's 4 shakes isn't right. No. It's just not, it's palate dependent. So you need to experiment with this stuff yourself. Got it. And it becomes much easier if you just focused on mash chemistry, let's forget about water chemistry, mash chemistry,
Yeah.
and then flavor chemistry, right? So I would then achieve what I needed. So for this beer, for instance, this was like a 2-to-1 sulfate to chloride, where that brown ale was 2-to-1 chloride to sulfate. And you just have to do the math. There's plenty of calculators out there to do it.
Yeah.
Tell you how many grams you need and whatever. So the other thing that I was doing is most of these beers worked out such that I was adding calcium to my HLT. I was treating all of my water with calcium chloride. In some cases, adding like 10 grams of gypsum or 10 grams of calcium chloride to achieve what I needed in the mash.
Yes.
With a little bit of acid to help the rest of the way. Otherwise, downstream, I would just have too much calcium chloride to deal with.
Yeah.
So you'd get close with because you need to get, so I was always focused on trying to get to like 100 to 150 ppms of calcium, and however much chloride or sulfate that equated to, then I would adjust in the kettle.
Wow.
Simplify.
Look at
right?
you. Yeah.
Simplify.
Simplify.
I know it sounds complicated, but if you compare it to
What we were doing.
Yes. By we, I mean a group of hobbyists.
Yes.
Not just these two dudes. I think we're overcomplicating it, and I think Gordon Strong would agree in that book.
Got it.
Right. So Gordon Strong even takes it to another extreme, where he holds his crystal malts and his roasted malts out of the mash. So whenever he mashes, he is just focused on getting 85% of the grain to convert properly. So he's already won 85% of the battle.
Yeah.
And then he puts the flavoring stuff in. At that point, you don't care about mash chemistry.
Yeah.
And then he worries about what do I need in the kettle.
That's crazy.
Right? So that's the way, in my opinion, it should
evolving.
go.
Look at
it's
that.
evolving. That's the way it should
All right.
go.
So what did you learn with this? Because this
So
is
the one thing that I've
this is
learned.
beer 4 or 5.
This is beer number 4. Number 5 was coming in the future.
Yes.
But so what I learned was the big thing for me has been, I think the proper mash chemistry has solved my attenuation issue.
Interesting.
The only way I'm going to know that is in a couple beers here coming up in the future, is to maybe go back to direct fired, but use the same chemistry approach.
Right.
And see if I get the same attenuation. Like maybe, like this is going to be a good beer for the summer. I will probably rebrew this, but in the direct fired mash mode.
Right.
And see if I can achieve, because what the concern with direct fired mashing is that as I'm recirculating the whole time, is that I'm superheating the worts under the false bottom, denaturing the enzymes, and just bringing that back up to the top, and eventually killing the enzymes.
Yes.
So you get plenty of extract,
Right.
but it's not well converted.
Right.
And I think that's what was going on with my direct fired mash tun. As much as I love the precision of getting the right mash pH, in fact, there was a comment on a video the other day about this.
Yeah.
I hope that guy's listening, but I really enjoyed being able to dial in precisely what my mash temperature is. But for these beers too, I've also noticed, and I noticed before I started this project, that if you mash in at 150 and you mash in at 155, I know this is going to be heresy, but you know what? You can't taste that difference. You can't. You can't, despite the fact that people have told us you can.
Yeah.
I dare you to try it.
Well,
getting everything else right.
That's another video.
Get everything else right.
That's another video.
You probably won't taste it. It's certainly inside. Don't brew those two beers side by side. 150, 155, and have someone give you a blind taste test. You'll probably have a hard time picking it out in a trial. Brewlosophy has showed this several times, actually, that a lot of these variables we hold near and dear to the heart as being end-all, be-all, black and white issues. They're like 1052 and 152 and 154. Those are wildly different beers. I'm sorry, but it's just not the case.
Exactly.
Especially if everything else is right. So I don't want this video to go on way too long, but it's already too long.
But I think there's a lot of information here.
Yeah.
And you had a lot of this pent up inside of you. And now it's out there on the internet. But I think it's all about, like, you had this issue, you took the steps to figure this out, and here you are, like, talking about, like, look, I need to figure out mash pH, I got that, and now I'm ready to go into and see if my little, like, equipment thing, where I'm going to direct fire this mash to, like, recirculate it, to, like, get the, you know, the temperature right for, like, what, the 60 minutes I need to, like, mash it? And see if, like, it really was all in the pH to fix. Since I fixed that using water chemistry, now I should get you know, my final gravity
Yeah.
to land where
Yeah.
I want it to be all the time.
Yeah, I mean the pH of this mash was 5.3,
mean,
and the pH of
seriously,
the homegrown hops was 5.4. So I mean, it's right in the ballpark. It's right there. And if I accept that as being true, I know that the pH for the 3 beers beforehand were right on the money too.
Okay.
So I think that's the big thing.
All right. Well, this has been educational for everyone, including me, because you kept this kind of like on your little computer here.
And we can talk about it more. People can put comments.
Yes, please.
And if we need to do another discussion, we can.
Because this is the thing. Like we talk, like water chemistry is this thing. Like you know what?
Don't let it be too complicated.
Yes, and I think that you've targeted what it should be about. Like at least for you, it's about the mash.
Yeah.
Like if you're gonna work on something, work on getting the right chemistry for the mash.
Yep.
So you can get that extract going.
Right.
And then, as you said, everything down the line kind of falls into place.
It'll all fall into place.
Yeah. Look at you. You're a trailblazer. That's what you are.
Trying my best.
Watch out. So, all right. Hopefully you learned something. Again, there's a lot here. So leave comments
heavy.
below and ask us more questions, because I think as you get along in the hobby and you start doing all grain and you start playing around with some of these bigger systems, especially with this guy with his brew stand and all that stuff, you know, I think these things come up. And again, like if there's problems in the beers that you're making, especially because I think if you sink more money into this hobby with the equipment,
you create more problems.
Well, that's like more money, more problems.
Yeah.
But I think that it should be more money, better beer. That's what I'm saying.
It better be.
It better be.
Yeah, right.
But if it's not, then like do what he did and like target the issue.
Yeah, like I said,
out.
I didn't want to brew the same beer 5 times, but I took the same approach 5 times.
And
I
that's-
solidified my process.
There you go.
That's what you've got to do, is you've got to be really, because once you have your process dialed in, you can then more competently make changes and expect what comes out the other side.
Yeah.
Right? That's what it's about.
Right on.
Awesome.
So, John and Mike, brew-shoots.com. Look, I just kept drinking because I knew you were going to talk a lot.
Excellent.
Brew on.
Cheers.